Hey everyone, welcome back to the fourth and final part of the MAT1033 practice final. It's questions 31 through 40. Number 31, we start off with a word problem here. It says we have a large explosion causes metal debris to fly into the air with an initial velocity of 96 feet per second. The main thing we want to take here is the equation. The 96t minus 16t squared is the height of the debris in feet, t seconds after the explosion. So at t equals 0 is when it starts. We want to know how long does the debris take to hit the ground. Well, if this thing is representing the height, if we want it to hit the ground, what is the height on the ground? The height on the ground is 0. Kind of strange example, but think about if your height, if you were 0 feet tall, you would just be on the ground. The top of your head would be on the ground. So that's why the height is going to be equal to 0. What we want to do is now solve this equation. We'll focus on solving this. And you can start solving this by factoring out the greatest common factor, because we do have something we need to factor. We have 96 and 16 have 16 in common, and t squared have a t in common. So when we take that out, 96 divided by 16 is 6. The t's gone. Minus 16, take out the 16 is gone, and we took out one of the t's, but another t remains, so we're just left with t equals 0. We've got it factored. Now we set each part to 0. Don't forget about the 16t in front. And then also the 6 minus t equals 0. 16t equals 0. Divide each side by 16 to get t by itself, and we get t equals 0. Now this is no good because this is when the explosion starts. It's not happening after. So that's not our answer. 6 minus t equals 0. If you add t to each side, then you will get your answer. 6 equals t. So if you go ahead and look at that, type in 6, you see that we do have our correct answer. All right, number 32. Number 32, we want to solve for x, and we have 4 over x minus 3 equals 3 over x plus 2. Now this is a fraction problem, so it can look a little intimidating, but it's just one fraction on each side. How do we solve that? Cross multiply. We want to cross multiply, and when we do that, we will get a familiar equation. So on the left, we'll have 4 times the x plus 2. And on the right, the 3 goes with the x minus 3. Now to finish solving for this, we want to distribute because we know we got to get rid of those parentheses. We get 4x plus 8 equals 3x minus 9. And then to finish solving, now we have no parentheses or anything. We want to get the x's on one side, subtract 3x from each side. We also want to get that 8 away. We can subtract the 8 from each side. And we get 4x minus 3x is just x. And then negative 9 minus 8 is negative 17. Let's just see that. There we go. X is negative 17. Number 33. Number 33 looks like a complicated one. We want to divide and simplify this expression. We have x squared minus 2x minus 24 over x squared minus 36 divided by x squared plus 12x plus 32 over x squared minus 64. Now there's two things you want to do here. The order you do them does not matter, but I recommend doing the order I'm going to do them in. You want to switch this division to a multiplication, and you can do that by flipping the fraction behind it. So let's do that first. And once again, I recommend doing this one before the other step, which I haven't described yet. We've got x squared minus 2x plus minus 24 over x squared minus 36. Change the division to multiplication, and then flip this fraction. X squared minus 64 over x squared plus 12x plus 32. Now, what's the other thing you have to do? Now you factor. factor everything. The reason why I do the flipping first is after you factor, you're really just in a spot where you want to cancel out. But if you have division, so if you do the factoring first before flipping and you have division here, you might cancel something out in a way you're not allowed. So it's easier just to flip first and then factor. Now, when we factor the top here on the left, we want two numbers that multiply to -24 and add to -2. That would be -6 and +4. Below here, we have a difference of squares. The square root of 36 is 6, so we get x minus 6 times x plus 6. Similarly, the top right, we have a difference of squares as well. The square root of 64 is 8. That's x minus 8 times x plus 8. And then on the bottom, we want two numbers that multiply to 32 and add to 12. And both positive, so that would be +8 and +4. Now, because this is multiplication, you can just cancel out anything on the top with on the bottom. The x minus 6 cancels out with the x minus 6. The x plus 4 cancels out with the x plus 4. And the x plus 8 cancels out with the x plus 8. So if we have a matching factor on top and bottom, as long as we have multiplication, just cancel it out. And what are we left with? On the top, we only have x minus 8. And on the bottom, we only have x plus 6. And that's all we're left with. We can check our answer here. And we got it perfect. All right, number 34. Another word problem. It says the following expression gives an approximate value of the total average credit card debt in a U.S. household T years after 1995. We have 394T plus 5,250. And T is the number of years after 1995. What do we want to know? We want to use this to predict what the total average credit card debt will be in the year 2023. So what it's asking us to do is telling us to plug in something for T, but what do we want to plug in? Well, we don't want to plug in 2023. We want to plug in how many years after 1995 is 2023. And that would be most easily done, not by just trying to eyeball and guess, but do 2023 minus 1995, which is 28. If you're not sure about this subtraction, think about if we wanted to do the year 2000. 2000 is 5 years after 1995, but the way you can get the 5 is 2000 minus 1995. That's all we're doing here. Plug in the 28, we get 394 times 28 plus 5,250. Now this is pretty big numbers to deal with, so I'm going to use my calculator. And when I use my calculator, I get 16,282. The average household, supposedly in 2 years, will have $16,282 in credit card debt. All right, 35. 35 is another one of the new equations. Oops, don't know why the answer is showing. Let's go ahead and get rid of that. We want to solve the equation the square root of x plus 26 equals x plus 6. Right. Now, anytime you deal with a radical equation, you have to start by getting rid of the radical, and you can do that by squaring it. But what you do to one side, you must do to the other. So we also need to square the x plus 6 side. And make sure you put the entire thing in parentheses like this. Now, the reason we do that is the squared exactly knocks off the square root, and you're left with just x plus 6. On the right side, you can't distribute the exponent because of the plus or minus. What you have to do is write out what it means to square something, which is multiply it by itself. And how do we simplify something like this? We have to FOIL it. Right? We have to FOIL x plus 6 times x plus 6. On the left side, nothing to do yet. We just have to FOIL this out. X times x is x squared, plus x times 6 is 6x, plus 6 times x is also 6x, plus 6 times 6 is 36. And 6x plus 6x, we can combine like terms to get 26 or 12x. We got x squared plus 12x plus 36. Now, how are we going to solve from here? We're going to solve from here by getting everything to one side because we have different powers of x, which means we're going to have to factor. We're going to subtract the x from each side and also the 26 from each side. We got 0 on the left and on the right, x squared, nothing changing with that. 12x minus x is 11x, and 36 minus 26 is 10. All right, so we've got our thing to factor here, our expression. We want the two numbers that multiply to 10 and add to 11. Now that's just exactly 10 and 1. Now that we've got it factored, we can set each factor to 0. We have 0 equals x plus 10, and 0 equals x plus 1. And solve each one for x. We have negative 10, subtract the 10 over here, we get x equals negative 10 for the one on the left. And on the right, subtract the 1, and you get x equals negative 1. Now, normally when it comes to factoring type problems, we're done at this point. I'm going to go ahead and box these in, but I am not saying they are both correct. Why am I not saying they're both correct? Whenever you have a radical equation and you have to square it like we did at the beginning, you may add in extra solutions or extraneous solutions, meaning either of these, both of these, or neither of these could be our answers. They are the only possible answers, but we do have to check. What we do have to do by checking is we plug in to the original equation. So I'm just going to look over here since it's not cluttered. I'm going to plug in negative 10 and see if it works. We got the square root of negative 10 plus 26 equals negative 10 plus 6. And all I'm doing by checking here is I'm seeing if I simplify, do both sides equal each other? You can do this by hand. You can do it in a calculator. I'm just going to do it by hand. So on the left, you have negative 10 plus 26 is 16 in the square root. And negative 10 plus 6 is negative 4. And the square root of 16 is not negative 4, it's 4. Does 4 equal negative 4? No. Since it does not equal negative 4, that means that negative 10 is actually not a solution. It was an extraneous solution. It's not really an answer. Now let's check negative 1. I know at the beginning I accidentally had the answer up, so we know this one's going to work, but you do need to check it because just because one of them doesn't work doesn't mean the other one will. They could both work, neither could work. Okay, so let's plug in negative 1 here. We got negative 1 plus 26 equals negative 1 plus 6. All right, just plugging in negative 1 there. Inside the square root, negative 1 plus 26 is 25. And negative 1 plus 6 is 5. The square root of 25 is in fact 5. We get 5 equals 5. Yes, that's definitely true. And because of that, it is actually an answer. Our only answer is x equals negative 1. Okay, a slightly added in wrinkle, but just be aware of that. Whenever you have a radical, you don't just get two answers. If you do get two answers and then not check them, because you do have to make sure you check them. All right, number 36. Number 36 says, use the quadratic formula to solve the equation x squared plus 2x plus 2 equals 0. Now it's telling you to use the quadratic formula, but you cannot factor this anyway because you're not going to find two numbers that multiply to 2 and also add to 2. So the quadratic formula, remember, that's x equals negative b, pretty much the newest thing from the class, plus or minus the square root of b squared minus 4ac all over 2a. And a, b, and c are the coefficients. X squared is being multiplied by 1, which is a. X is being multiplied by 2, which is b. And the number by itself is also 2, that's c. Now do remember that if there are minus signs here, then you include them. So if this was minus 2, C would be negative 2. It's not, but I just wanted to throw that in there. All right, but all we've got to do here, we've got to plug in A, B, and C. B is 2, so we've got negative 2 plus or minus the square root of 2 squared minus, I like to put the B in parentheses, even if it's positive, minus 4 times A, which is 1, times C, which is 2, all over 2 times A, which is 1. And what I recommend doing first is simplifying the inside of the radical. Don't really worry about anything else. 2 squared is 4, minus 4 times 1 times 2, which is 8, over 2 times 1, which is 2. And then 4 minus 8 is negative 4. We've got negative 2 plus or minus the square root of negative 4 over 2. Now, if you've been watching this in order, you know how to deal with the square root of negative 4. This is what we want to simplify before we move on. Anytime you have a negative in a square root, what do you want to do? It comes out as an I. We got negative 2 plus or minus. The negative on the 4 goes away. It's going to come outside. It's going to become an I. And then we have 4 left inside the square root. And then the square root of 4 is 2. So we have negative 2 plus or minus I times 2 all over 2. Now, maybe along the way, you may ask yourself, why didn't he cancel the 2's out here or out here? We have a 2. Why can't we cancel them out? You can't cancel out when you have a plus or a minus unless if you have a 2 in every spot. But we do actually have a 2 everywhere now. This 2 we can cancel out because we can cancel out with this one and also this one. If this was not a 2 or we couldn't cancel a 2 out here, then you actually cannot do this. But luckily for us, we can. And what are you left with? Well, the front we have, don't forget about this negative sign. We have negative 1 plus or minus I times 1, which is just I, over 1. And we don't have to write over 1. Now, once you have the plus or minus here, we have our 2 answers. 1 for the plus and 1 for the minus. We have negative 1 plus I and negative 1 minus I. If you go ahead and hit that, you'll see that's exactly our answer. All right, 37. 37, we have a 12-foot ladder is placed against a building. But for this kind of problem, it's very visual, so I'm going to draw it. We have our ladder, which is 12 feet long. We're on a building. And presumably it's placed on the ground. And if the base of the ladder is 7 feet away from the building, what that means is this length here from the base of the building, which is the bottom, is 7. It's asking us how far up the building will the ladder reach. Well, that's this side here, X. And what you want to remember about this sort of picture is we have Pythagorean theorem, a squared plus b squared equals c squared. Right. Now, the main thing you want to remember is a and b are either one of these sides. So the x and the 7, we can use a as x. We get 7, or x squared, and then b as 7. We get 7 squared. The important thing is the hypotenuse is always c, and that's 12. So we get 12 squared. But now we want to solve for x. We got x squared plus 7 squared is 49 equals 12 squared, which is 144. Subtract the 49 from each side. We get x squared equals 144 minus 49, which is 95. Now we do the square root to get x. At this point of the course, you might be thinking, oh, we have to do the plus or minus because we just learned about that. But the lengths are positive. You don't have to do plus or minus when you're talking about, a visual thing. The length x has to be positive, so no plus or minus to worry about. All we got to do is the square root of 95, and it says round your answer to the nearest tenth or 1 decimal spot. So we type in the square root of 95 in our calculator, and rounded to 1 decimal spot is 9.7. And that's our answer. Okay. About number 38. A few more to go, and then you'll be all ready for the final. Please use the formula V equals the square root of 20L to estimate the speed of a car in miles per hour based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road. A lot of words, but what we want to take is this formula. V is the speed and L is the length of the skid mark. At the scene of an accident, a police officer measures the car skid mark L. So it's telling us L equals 219 feet. What is V? What is the speed? Well, all we have to do here is plug in 219 for L. We get square root of 20. Notice the L, which is 219, is under the square root. What I recommend is multiplying these two numbers first. 20 times 219. They're inside the square root. We got 4,380, and we want to do the square root of that. Square root of 4,380 is about 66. And it says round your answer to one decimal place, 66.2. And if we go ahead and look at that, there we go, 66.2. Okay. About 39 now. 39, we want to simplify completely. We got square root of 5, parentheses, 7 plus the square root of 5. It gives you a little tip on how to write your answer. What we want to do with something like this is we want to distribute. So we got the square root of 5 times 7. 7 is not inside the square root, inside the square root, so it's just going to be 7 times the square root of 5 for the front, plus, but the back here, we have a 5 inside a square root. When we multiply a square root by a square root, it looks like this, but we can multiply the numbers inside together. So 7 times the square root of 5, one's inside the square root, one's not, so it's simplified. Square root of 5 times square root of 5, we can multiply the insides because they're both inside a square root, and we get 25. The square root of 25 is 5. We got 7 times the square root of 5 plus 5. And that's it. It gives you a little hint on how to write it, but we can just look at the answer here. Yes, they switch the order, but it's just a plus, so I can write the 5 in front if I want. And then finally, number 40. Simplify the following completely. We have y. It's probably small on your screen. It's to the 17 over 5 power times y to 13 over 5 power. Now, what do we do when we're multiplying things with exponents with the same base like this? We rewrite the base and we add the exponents. 17 over 5 plus 13 over 5. Now, what you want to remember when you're adding a fraction here, kind of do it on the side so it's a little easier to read. We already have a common denominator, which means we can just add the numerators and write it over the common denominator. 17 plus 13 is 30. 30 over 5 is 6. So in fact, this exponent on y simplifies to just 6, and that's all there is. And we can check. It actually did not simplify the 30 over 5 to 6. I'm not sure why. Let's go ahead and just do it. Y raised to the 6th power. You can see that it does simplify to that. All right, but I hope this help prepares you for the practice test, and best of luck on the real final exam.